Hello class, in today's video we're going to be going over making predictions using the line of best fit. The learning intention of this video is we're going to be able to use the line of best fit and its equation so that we can actually estimate data values that are found within the dataset as well as outside the dataset. And lastly, we're going to briefly look at the reliability of those predictions that we make using the line of best fit. In our previous lessons, we've already looked at what is the line of best fit. We said that the line of best fit is simply a straight line that helps summarizes the trends found within the actual scatter plot itself. And when we actually draw the actual line of best fit, we try to make it such that it's kind of taking the average of all the data values along with it, okay? And we said that there should be roughly the same number of points found above the line of best fit as well as below the line of best fit, okay? And then we looked at how do we actually find the equation for the line of best fit. We said that all equations of a straight line kind of follows the general rule, which is y equals mx plus c. And we looked at several examples of how we could actually calculate the gradient as well as the y-intercept. In this lesson, what you're going to be doing is after you've actually mastered how do you actually find the equation, we can now start to look at how do we actually make predictions using the line of best fit, because this is what the line of best fit is actually used for, okay? And I can confirm that you will require a big brain, so you will require all your brain cells to actually understand and do this, because this is found to be a very challenging topic for most U10 students. Now, there are two types of prediction methods. One of them is called extrapolation. The other one is called interpolation. But to help you guys really understand and differentiate between these two methods over here, I am going to take a literacy focus so that you can actually differentiate. And hopefully, I'm hoping that it's going to actually help you memorize these two as well. So in this case of here, the prefixes are the words inter as well as extra, and you guys probably have already encountered what these prefixes are. So for instance, the word inter-school sports contains the word inter, and the word extraordinary contains the prefix extra, okay? And from your understanding, you probably know that inter-school sports means you're competing between different schools for different sports, okay? So in this case, inter means between, whereas extraordinary means it's not normal or it's beyond normal, okay? So in this case of here, the prefix means between and the word extra means beyond or outside. Now, how is this going to help us understand what interpolation or extrapolation is? Well, I already told you guys that these two methods over here, they are just ways that we can actually predict values. So in this case, interpolation means you're estimating values that are found between known values, meaning that it's found within the actual data set itself, whereas extrapolation involves estimating values that lie outside of the range. So I've got some visual displays over here down below that will help you understand what I mean by interpolation versus extrapolation. So for instance, if I plotted all of my values into a scatter plot, this is what I would have over here. And if I'm interpolating, what I'm actually interested in is I'm actually trying to find out what is a value that's kind of present within my data set, but I didn't actually find it myself. So for instance, I want to know at when it is 21 degrees, how much sales would I actually make? So in this case of here, because I don't actually have a data value here, I'm actually making that estimation. So using my line of best fit, I can kind of roughly see that I'm going to roughly be making $480 worth of sales when it is 21 degrees. So this is interpolating because I'm estimating that a value that's found between two known values. So in this case, the smallest to largest, or in other words, I'm finding a value that's found within the actual data set itself, whereas extrapolation is the opposite of that. I'm trying to find a value that's found outside. So in this case, if you notice that the range of my data set is between these values over here, in this case, I'm trying to find out what is the number of sales when it's 29 degrees, which is found outside of the data set, which is why I've kind of indicated it by these dashed lines over here. So in this case, if I was to eyeball it, this is going to be roughly $740 worth of sales, okay? Now, when we are either interpolating or extrapolating, or when you're trying to find a value within the actual scatter plot, there are two ways that we can actually estimate the value. We can either estimate the value graphically, meaning that you're just going to eyeball it from the line of best fits, or you could actually use the equation for the line of best fit that you've generated to actually work it out. So this involves a bit of calculation, okay? Now, each of these methods has its own advantages and disadvantages, and we're going to shortly see what these are. But in essence, just to summarize it, eyeballing it is very inaccurate because it's quite subjective, whereas when you're using the equation, because you are kind of like working it out and doing it methodically, this is going to be a lot more accurate, okay? So let's look at how do we actually estimate values graphically, meaning eyeballing it or judging it from the actual graph itself. So in this example over here, I'm going to show you what it means to eyeball it, and I'm going to show you why this method is probably not as accurate and why I prefer you guys to not use this method, okay? So in this case over here, the example reads, predict the cost to find a party if 20 people attended. So cost is along your y-axis, so you're trying to find the y value, okay? And it's saying that there are 20 people has attended, so your x value is 20. So x is equals to 20 lies over here. So I'm going to draw a line like this. And if I was to eyeball it, notice that I'm trying to find out what this value is. So I'll just have to make a judgment what I think this value is going to be. In this case over here, I'm going to say it's going to be roughly equal to 550, but I'm making an approximation, okay? Because I'm kind of guessing what this value is, there's not a very high level of certainty. Because there's not a high level of certainty, this is why eyeballing a value, okay, or doing it graphically is not a very accurate or a reliable method at all. What I'm going to show you now, okay, is how do we actually estimate values using the actual line of best fit equation. So in this case, I've got an example, and the example reads, use the equation for the line of best fit to predict the value for y when x equals to 3. And I've already been given my equation over here, okay? So in this case, I'm trying to find out the value of y. So this is my equation over here. So I'm going to sub x equals to 3 into my equation. So what that means is wherever I see x, I'm going to replace that by the number 3. So if I do that, in this case, it will be y is equal to negative 0.7. Now notice that there's no symbols, that just means a multiplier. So I'm going to be multiplying these two values over here. And because I'm solving for y, I just try to get y by itself. So in this case, I'm just going to simplify my equation. Negative 0.7 multiplied by 3 is negative 2.1. Add these two values together. Therefore, I'm going to get a value of 6.9. Okay, so this is a very straightforward and the most basic example there is. The next example we're going to look at is going to be a tiny bit harder, okay? Now, the difference between this example as opposed to the last example is that I'm now solving for x, I'm not solving for y anymore. And you can see that there is a different procedure in place. So in this case of here, I'm now going to be subbing in y is equal to 5. Notice that this is the exact same diagram, so exact same equation. So I'm going to sub y is equal to 5 into my equation. So therefore, wherever I see y, I'm going to replace it by the number 5. If I do this, this is what it would look like. Okay. Now, what I'm trying to do is I'm trying to solve for x. What I mean by this is I'm trying to get x by itself. So notice that your x is found on the right hand side of the equation, and you've got numbers such as negative 0.7 and 9 in place. I'm trying to get rid of this. I want x by itself on one of the sides of the equation. So what I do is I actually need to use inverse operations so that I can actually isolate or solve the letter that I want to solve, in this case being x. Okay, so what we're going to do first is we're going to get rid of this guy over here, okay? Because this is a separate term compared to the negative 0.7x, because notice how x is combined. We have to get rid of this guy first, okay? Notice that the sign in front of the 9 is a positive, so inverse means that we have to use the opposite sign. So to get rid of positive 9, I'm going to subtract both sides by 9.0, okay? Whatever I do on one side, I must do to the other side of the equation, okay? So in this case, 9 take away 9 is 0. So notice how inverse operations, they kind of cancel each other out. So in this case, if I do this, it will now become 5 minus 9.0 equals to negative 0.7x. I then just simplify the left-hand side of the equation. So now it becomes negative 4 is equal to negative 0.7x. The sign in between these two numbers over here, or letters, or whatever these are called, is a multiplication sign. So again, I'm trying to use inverse operations, okay? So to get rid of the negative 0.7, I'm going to have to divide it, since negative 0.7 is being multiplied by x. By using these inverse operations, this will get rid of the negative 0.7x. So it will be x is equal to negative 4 divided by negative 0.7, which is therefore equal to 5.7, okay? And I've kind of rounded up to one decimal place since all these values have one decimal place in its equation. As you can see over here, this example is far more complicated than the one previously, and this is generally going to be the case when you're trying to solve for x. Now I want you to have a go at attempting this question. So again, use the other examples that we've just went through so that you can actually answer these 4 questions over here. I'm just going to give you a head start. So in this case over here, you're trying to find the value of x. So therefore, sub y is equal to 36 so that you can solve for x. In this case over here, because you're subbing in for x, this is going to be a lot longer. And this one over here, you're subbing in y is equal to 73. In this one here, you're subbing in x is equal to 4, sub x equals to 9 into the equation to solve for y. So give yourself 10 minutes to answer these 4 questions, and then we'll go through the answers together. Alright guys, so I'm going to go for the first solution. So for part A, find out the value of x when y is equal to 36. So in this case over here, I've subbed y is equal to 36. So therefore my equation, okay, this is the equation of here, sub y in, so 36 is equal to blah, blah, blah. But what I'll do now is, since I'm trying to solve for this guy here, I want to get x by itself by get rid of this guy. So I'm going to subtract both sides by 16.649, and that in doing so this will cancel this guy. So now I'll just simplify the left hand side of the equation. So if I do this, this will now become 19.351 is equal to 5.2571x. Now to get rid of this guy over here, because I want to get x by itself, I'm just going to divide both sides by 5.2571. In doing so, x is now equal to 19.351 divided by that number, and if you put this into a calculator, then you're going to get an answer of 3.6809, okay? Now for part B, similar process, substitute y is equal to 73. So this is what it will be. Again, I'm going to eliminate this guy here by subtracting both sides by 16.649. I will simplify it, then divide both sides by 5.2571 and put this into a calculator. You're going to get an answer of 10.719, okay? Part C and part D is going to be relatively more straightforward. There's less steps in this case. So I'm substituting in x is equal to 4 into this equation over here. So this is what it would look like. Find out what this product is going to be. So multiply those two numbers together. This will equal to 21.0284, and then add them together. Therefore, your answer is going to be 37.6774. And do the same thing for part D, and therefore this is going to be your answer. Now, if you guys did this successfully, then great job. But if you guys still struggle to do part A and part B, don't worry too much. We're gonna go through more examples in today's lesson as well as future lessons, so don't stress out. What I want you to do now, class, is I want you to have an attempt at answering this word problem, okay? Now, this word problem is probably going to be a very close example to the one found most likely on your test, okay? So there's a word problem. The first part wants you to find the equation of the trend line. So in this example over here, this is going to be your line of best fit, okay? And what you want to do is you want to use these two coordinates to be able to find the equation for the straight line. So do that. Then for part B and for part C, then use your actual equation so that you can actually make predictions. So give yourself 15 minutes or so to answer this question, and then compare your answer with my answer. Now, if you guys done this successfully, okay, what I'm going to do first is I'm going to label this as x1, y1, x2, y2. The reason why I'm labeling this is so that I can actually find out my gradient, okay? So in this case over here, this is the formula to calculate your gradient. So what I'll do next is I'm going to just substitute x2, y2 and stuff like that. So y2, as I said, was 60, okay? So it'll be 60 minus 30 all divided by 60 minus 40. So again, I'm just going to write that just so you guys know what I am doing. And what we do is just simplify this using our calculator. So therefore 30 divided by 20 is the same thing as 1.5. And once I've found that, I can then substitute that into my general formula. What I now do is I'm going to try to solve for C. So I'm going to substitute one of the coordinates. Remember, I said to use the easier one or use the one with the lower values. So in this case, I'm going to be substituting 40 and 30. So if I do that, 40 is where x goes, 30 is where y goes, so this is what it will look like. I'll now multiply these two numbers together, and that will give you 60. So 30 is equal to 60 plus c. I'm trying to solve for c, so get c by itself, so kick this guy out because we don't like him. So in order to do this, since this is a positive 60, we'll do the reverse. We'll do the inverse. So we'll subtract both sides of the equation by 60, and by doing so, it will now become c is equal to 30 minus 60. C is therefore equal to negative 30. So that over here is my typo. So the equation should be 1.5x minus 30, okay? Once we've got the equation for our line of best fit, then we could actually start to make predictions, okay? So part B reads, use your equation to estimate a literacy score if the English score is 50 and 86. So now, in this case, I want you to please note what your y-axis is. So your y-axis is your literacy score. So in this case, what you're doing is you're trying to find out what is the y value when x is equal to 50 and when x is equal to 86. So I'm going to be substituting x is equal to 50 to solve for y, and then do the same thing. So sub x is equal to 86 to find the corresponding y value. In this case over here, 50 lies over here. So you're trying to find out what is this y value, and 86 is an example of extrapolation since it's beyond outside of the data set. So again, I'm trying to find out what is this y value over here. So let's just sub in x equals to 50 into the equation, okay? So therefore, it'll be y is equal to 1.5 multiplied by 50. Put this into a calculator, and you're going to get an answer of 45. Now, I'll do the same thing for part 2. So sub x is equal to 86, okay? And then if you do that, then you're going to get an answer of 99. Now, it's really critical that you guys actually write worded statements in this case over here, because you haven't really defined what your x and y variables are. So that's why you have to say, since y over here corresponds to the literacy mark, you have to say literacy score is 45%, and it's very critical that you do include the units when applicable or provided in this case over here. Now that we've answered part B, we can then answer part C, which is going to involve a bit more steps in this case. So you're trying to find out what your English score is. So you're trying to find out what your x value is going to be. So we want to substitute y is equal to 42 in this case. So if you do this, what we do now is we're going to get rid of this 30 here. Notice this is a negative 30. So I'm going to do the opposite of a negative 30 by adding both sides by 30. So if I do this, it's now going to be simplified to 72 is equal to 1.5x. I now get rid of the 1.5 by dividing both sides by 1.5. So x is equal to 48 in this case of here. So again, write an English statement. So English score is therefore equal to 48%. And for part 2, do the same thing. And if you did it successfully, then you should get a score of 99%. Now, the last thing that I want to go through before I get you to actually work on the textbook questions is talking about the reliability of the predictions using either extrapolation or interpolation, okay? And there's really only one thing that you need to know, and it's that when you're estimating values specifically through extrapolation, I want you to note that this might not be a very accurate estimation, okay? And the reason why it might not be an accurate estimation is because what you're doing is you're assuming that this that all values found outside of the data set follows the same linear trend. So in this case, if you notice that most of your data set is found over here, okay? So in this case, if you're trying to make an estimation for values, let's say over here, what you're doing is that you're assuming that all values found outside follows a linear relationship, which is why I've kind of represented this by these dashed lines over here. However, that might not be true, because in reality, what might happen instead of following a linear trend for values outside of it is that it might actually curve like this over here, okay? We can't be too sure that values found outside of this follows the same trend, which is why I've said this over here. Hence, it assumes that the estimated values follows the same trend, which may not be true. But also, other than this, you might encounter some anomalies or things that might not make any sense whatsoever. So let me show you one example what I mean by this. Now, can you guys remember on the earlier example before, we said that in this case over here, when you've had a literacy score of 87%, so where is that? 87, let's just say, is roughly around over here. We said that you're going to get a score roughly of 99%, which is what we've calculated over here, okay? So literacy score 87 corresponds to 99%. Well, what would happen, let's say that you scored 90% on your literacy score? What would that mean? Well, in this case over here, because you've achieved 99% for 87%, what that would imply is that you're going to get a English score that's greater than 100%. And we know that you can't really get a percentage or a score greater than 100% because it just doesn't make any sense, since 100 is full, it's complete, it's the whole. So in this case, I'm showing you one clear example why extrapolation is not always going to be accurate. It just doesn't make sense sometimes. What I want you to do now, guys, is I want you to answer 5 textbook questions from exercise 9H. So I'm going to get you to answer question 2, question 3, question 4, which is going to take you a bit more time since you need to actually plot these values over here and create your line of best fit, make estimations. Question 5, which is a bit more shorter than question 4, as well as question 8, okay? This is the end of today's video. Hopefully this video has helped you. Please email me if you need me to explain any further things if you don't understand. I'll see you guys again in the next video. Bye.